What's up, kiddos? Welcome to the last section of Chapter 8. I feel like a radio announcer. It's kind of crazy. Section 5, Chapter 8. Whoa, did I say last section? Oh, you know what that means. It's soon to be game time, baby. That means this. You're about to have a chapter exam. I'm so excited because you guys are going to do so well. I'm going to love grading them because you're going to do great. Alright, here we go. You'll need your notes. And as you see, oh, that little man means you're going to be doing some note taking. So let's draw this example in your notes. What you see is a couple things here that's given to you. You see the triangle. You got this side FA is given to you to be 12. You got this side BA. Ooh, probably shouldn't say that. AB is actually 8. And AT is given to you to be 14. Now there's something else I want you to notice that's extremely important. That's this right here. Don't miss this. Don't miss this. Those two things right there are parallel to each other. So what I'm going to have you guys find, and we're going to use this example to lead to the next theorem, but what I'm going to have us find together is the length of BN. So let me pull this over here so you can see how this actually flies. I'm going to move this over. Hold on. Bear with me. Okay. So as we keep on rolling with this, what you see is these things are given to you. Things are parallel, and I'm going to show you if I pull out these two triangles that's here, the bigger triangle. Ooh, that's right, I pulled that out. Look at that. Ha. And I pull this guy over here. Oh, that's nice. Okay. So what you see is this. Right away, just like I would, well, just like you would, you see that this angle is congruent to this angle. Mr. Motter, why is that the case? Well, you know it just like I do, because this line is parallel to this line, therefore parallel lines imply congruent corresponding angles. Same argument, guys. That means this angle is congruent to that angle. So that's these two. Well, Mr. Motter, who cares? Here's why this is extremely important and why you should care. Because now that you see this triangle on the left and this triangle on the right are similar through the well, that's pretty high. Squiggy theorem. Why is that important? Because since we know now that these triangles are similar, their sides that are corresponding are proportional. And that means this, ladies and gentlemen, we're getting so close. We got this, which is this side right there, and that corresponds to this entire side of that triangle, which, by the way, is the entire side over here. So there's my ratio. I will go 12 is to 20. Where did 20 come from? Again, it's 12 and 8, the whole side length over here. And that's going to equal this side, which, by the way, is 14. And that matches up in this triangle over here to the right with that side, which, by the way, oh, is the thing I'm trying to find, BN. So there is your proportion, 14 over X. So when I dream of Genie, which I don't, but that's how we do the problem, and we dream of Genie right here. So if we do means, extremes, wrong way, means, extremes, better, product theorem, which gives me 12x, and I take 14 times 20, that gives me 280, I do believe. So when I divide 280 by 12, I'll pull my little candy dandy calculator here, 280 divided by 12, bam, that gives me, that's right, a 23.3, a decimal as an answer. That's totally cool, it's legit. Legit as it's going to be. 23, just kidding, it's the answer. 23.3. So that's cool. So that right there gives you that answer. So piece of cake. We can do that through proving the triangle is similar. Now here's why I did this. Let me pull this out of the way. I'll move this over. Bear with me. Hold on. Hold on. I got it. Bing. Okay. So now that we got this, we got 23.3. I'm not sure if you see this or not, but you should put this in there. Now let's say that FT is 15. So the question's a little different now, a little bit. Well, no, it is, because now I'm asking you to find Tn. So let's find the length of Tn. How do we do this? Well, we're going to do it exactly like we just did the other one. Let me pull this back over here. Boop, I'll put this up here. I'll move this over. I like this. Okay. So here we go. So now, when you look at this, I've already pulled out the triangles, and we did the same thing, same argument. This angle and that angle are congruent because they're corresponding, and parallel lines imply congruent corresponding angles. Likewise with these two angles right here too. I've labeled all the sides, and what's cool is this. I can apply the same exact theorem. Well, not it's really a theorem. I can apply the same exact concept because since I know the triangles are similar, the corresponding sides are proportional. So let's do this. Let's find some proportional sides or corresponding sides. So I'll do the same thing. I'll go 12 is to 20. So here's 12 and that whole thing 20. So 12 is to 20. Now I'm going to pause for a second because I want you to remember what we're actually trying to find. We're trying to find the length of Tn. If you look over here in this triangle, I'm guessing, but it's about right there. So that piece right there is actually not an entire side of the triangle. So we got to be tricky in how we do this. We still have to set up a proportion over here, a legitimate proportion. So we have to find a pair of corresponding sides that'll work. Now you could use 14 and 23. They certainly correspond, but that's not going to help you do much. It really isn't. What you need is this. Why don't we go with 15, and that would actually be corresponding to that whole side right there, and we'll say that that side right there is y. Why not? I don't know. We made a y, so there we go. So I will go 12 is to 20. That's 12 is to this whole side, and then the other corresponding pieces is this. 15 is to y. So there you go. So when I take this, dream of genie again, yeehaw, that gives me 12y equals 300. Ooh, 300. Sparta. Like the good old movie. So let me show you this. I'll clear this. So we go 300 divided by 12, and that gives you an answer of 25. So your answer for this little piece, no, be careful, be careful. 25 for y is what this gives you, and that's cool, but remember what y is. It's this entire side length. That's not what we're looking to find, but it does help us get our answer, because if the whole thing is 25, and you know this piece right here is 15, therefore what remains? 10. Well, you got it. So therefore we got that side to be 10. Now I'm going to show you, you can totally, guys, you can totally do it this way. There's nothing wrong with it, but I'm going to show you a shortcut of how you can get this answer 10 pretty quickly. I don't want to say it's any quicker. It's just a different way and a different thought process, which actually leads to some other theorems down the road. So, okay, so we got this side here to be 10. We know this is 15. We know this is 12. We know this is 8. Next question of thought, really, system of thought, is this. What if I asked you for the ratios of these? Of this side to this side, and then this side to this side. Well, you might not see it yet, but check how cool this actually is when we do it. If I take FA, which is 12, I'm glad I made it AB and not BA, huh? Yeah. And then I take that over AB, which is 8, and I take FT over here, which is 15, and I put that over TN, which is 10. Well, that doesn't really seem like it's a big deal. It isn't until you look at this. That's reduced 12 to 8. When I reduce 12 to 8, ladies and gentlemen, that gives me 3 halves. Okay, Motter, so what? Get ready. This is going to be cool. You better sit down if you're not. If you're eating something, be careful. You might choke. I don't want you to do that. Check this out. 15 over 10. If you reduce that, by golly, you got the same exact thing. So what does that tell you? It tells you this. Anytime you actually have a side like this that's in a triangle, make it yellow. So let's say this. Anytime, oh, it's a weird, yucky yellow color, whatever. So anytime that side is parallel to this third side, what it actually does is it divides the sides, this side right there, and this side right there. It divides those sides proportionally. And ladies and gentlemen, it is actually leading us, as I just said, to our next theorem. Oh yeah, and that's right, you better write it down. It's theorem 65. Here's what it says. If a line is parallel to one side of a triangle, and it intersects the other two sides, so that's the one that kind of right through the middle, not exactly the middle, we're not talking midline, but if that's the case, then it divides the sides proportionally. And the name, I love the name of this, it sounds so tough. It's called the Side Splitter Theorem. Oh yeah, the Side Splitter Theorem. So let's go back a second and let me show you a little shortcut, potentially how this is going to look. I think it's really cool. Let me go back. Okay, so if you look at this question right here, let me go back. There. Now remember, we have this. We have this guy right here. Here's what it was before. So if I know this thing right here is parallel to this side right there, I don't know if you see this or not, guys, but I see this right away. I see a proportion setting up very, very quickly in this. This right here, whoop, I see an equal sign right in here, a good old equal sign. And what I see is 12 over 8. So 12 over 8 equals 15 over whatever I'm looking for right there. And that, ladies and gentlemen, is another way that you can totally do this. Nuh-uh, does it really work out right? Oh yeah, because when you do means and strings product theorem, that gives you 12x equals 120, and that means x right away is 10. Whoa, I have no idea why I put that. X right away is 10. So I don't know if it's a shortcut or not for you, but I'll tell you what, that is awesome. So I don't know, but to me, that's a nice little shortcut. So let me get you this. Let me get through here, through this. What I'm going to do now is give you this example. You see the same thing, same type of picture. You got BE parallel to CD, and you got these things labeled in there. I'm going to have you find two things, guys. I'm going to have you find ED, just like we did in the last example, and I'm going to have you find CD. CD and ED is what I want you to go find. Those guys right there are already up there. Good luck. I believe you can do it. I'll see you in class. Later.